Hello.
Yes, sir.
Okay, all right. Okay. All right, recap. So, what did we learn so far? So, the purpose of this course is to get used to various paradigms of programming. So, and we have seen we have seen functional paradigm, in which the idea was that computation or programming is I'm using a more formal name for programming, which is computation. Computation is evaluating functions, yeah, or more precisely, substituting and reducing expressions. Yeah. This is what was functional paradigm, and procedural paradigm was based on your notion of what is an abstract machine, yeah, which has registers and which has memory and all those things that we are all familiar with. So now we have seen functional paradigm to some extent. Now let me introduce you another paradigm, which is programming logic programming paradigm. Okay, which is saying that computation is basically is reasoning or proving proving facts. Okay, what do I mean by that? If I say all men are mortal and Socrates is a man, you might have seen this before, then why? Then what can you conclude?
Socrates is mortal.
Yeah, you can conclude that Socrates is mortal. Now, so basically that's computation, because if I want to compute if Socrates, if I want to compute mortal of X, okay, then from where I don't know who is mortal. Okay, if I just want to compute who is mortal, and I ask my system who is mortal, so instead of asking who is mortal, I say mortal of X and now find me X. Then it will go back and uh, it will compute mortal of X from given facts. What are those facts? Man of Socrates. Okay, that's a fact. Another fact is if man of X implies mortal of X. Yeah. Okay, what do I mean by these two things? Mortal of Socrates. I'm just writing how you S5 students are taking logic this semester. Yeah.
Yes, sir.
Yeah. So now you might have seen first order logic. In which so basically how many of you are here who are not familiar with first order logic? I'm not saying that you need to know, but it's much easier if I have a understanding. I think MTech students, have you seen first order logic before? No,
Yes, sir.
you have seen first order logic. Yeah. So basically what it says is that I have objects and I have relations. For instance, here an object is object not in the object oriented paradigm sense. First order logic deals with objects and then relationship between them. Okay, so Socrates is one object, man is a relation, man of some. So something is a it is a property of objects. Yeah, being a man. Yeah. Okay, so from these two things, I can these two facts I can compute what is the value of x for which mortal. Okay, we are still at this. Uh, I mean, may not be easy to understand yet, but as we go along, you will understand. Okay. Now, what we are so prologue stands for programming in logic. Okay, it's a very old programming language, and more than it's a rule based declarative programming language. Okay, what do you mean by rule based? Rule based means that there are facts and rules. Okay, and computation is essentially query answering. All right, what do I mean by that? I mean that to a prologue system, what you're actually giving is things like this. You say man of Socrates. You say if something is a man, then it is a mortal, and so on. Okay, so this is a fact. Man of Socrates is a fact. Man of X implies mortal of X is a rule. So you are supplying to the prologue system, you are supplying basically rules and facts, and then you are actually asking. Computation is essentially query answering. What do I mean by that? You will essentially ask, who is mortal of X? Yeah, it's a query. It's a query to the system, who is a mortal, and then prologue will answer us. Typically, I'll just show you an example. So let's finish the command here. Okay, so these are my rules. It's a fact, man of Socrates and man of X. So essentially in prologue, you will write it the other way. You, instead of saying man of X implies mortal of X, it will say I can prove mortal of X if I can prove man of X. Yeah. In other words, mortal of X is true if I could prove man of X. Okay. All right. So now there is already color. That is because I have installed in my Atom. The Prolog Atom is the editor I'm using. And in this, I have put the syntax formatting for Prolog. And so I have given these two. Okay. Now we will be using SW Prolog. Okay. So you can just search for SWI Prolog, and then it will come. You just if you are using Linux, just put aptitude apt-get install SW Prolog, and then it will come. Otherwise, you just download from here. Okay, SW Prolog. Okay, so now I have these two rules, and I started a SW Prolog, and I am going to enter this file. Okay, and the thing for Prolog will be consult. So compiling a file will be consult, and my intro.pro, and if I do this, it says true. Now if I ask mortal of X, if I 1 second. Ah, so if I ask who is man, uh, 1 second. Uh, okay, so it seems like a man is already a defined function in the library, so I have to use something else. Uh, yeah, human. So let's just human. Okay, so I wanted to show you, sorry for all the trouble. So I have these two rules. One is a fact, human of Socrates. The other is mortal of X, and I am writing in the other way. So if P implies Q, I am actually writing Q if P. That's how we will write it. Okay. This you can read it as if mortal of X if human of X. Okay. All right. So I have this fact and I have this rule, and I have loaded this uh, file into my Prolog system. And now I can ask who is a man. Okay. If I ask who is man of X, then it will show me, or not man again. If I ask who is human, then it will say Socrates. Okay. Now, if I have more men like Plato. Okay. If I have more men, more human, so I should not. I should also, to counterbalance, I should use some females also. Can somebody tell me a female philosopher's name?
So Ada Lovelace, but that's a
Ada
mathematician.
Lovelace is a computer scientist, but what was her name? The Greek female philosopher. Who was she? The one who was in Alexandria. Okay, let's just Google it. Female philosopher, Alexandria. Her name is Hypatia. Okay, Hypatia was a famous geometer, and she was from classical Greece, Egypt, and she was killed, and it was by the Christians. Okay. All right. So now, if I ask who is a human, it will show me Socrates is a human, and Plato is also human, and Aristotle is also human. What happened to Hypatia? I haven't saved the file, that's why Hypatia didn't come. So I'm actually pressing semicolon. Then it will actually giving me other possible answers. Okay, and Hypatia. So we got all humans, and who is a mortal? Mortal of X. Sorry. And then it will, all of them are mortals also. Okay, so that's the idea. So we have facts, and we have this one. All right. Okay. Now, how many of you are in front of your machine? All of you?
Yes, sir.
Can you quickly install SW Prolog?
Sir, what was the command?
If you are you in Linux?
No, sir.
Yes, sir.
Those who are in Ubuntu or similar thing, you just type apt-get install SWI Prolog. I think this is the one. What you can do is that you search for apt-get apt cache search SWI. Okay, you do this apt cache search SWI, then it will show you all the packages which has SWI somewhere, and then you find out what is SWI Prolog and install. Okay, others go to SWI Prolog, this site, prolog.org, and then download. Those are in Windows. Yeah, it's here. All the commands are here. So those who are here, just Windows. But in any case, all of you should have Linux installed. or some sort of a Unix. How many of you are installing? Hello?
Yes, sir, we are on it.
All right. Hello?
Yes, sir.
Managed? You managed?
Yes, sir. Some of us, I think, got installed.
Okay, can you try this example? And then once you get this example, we can move forward. Just open a file and type in this human of Socrates dot and this one, and then whatever I have done. Then we can move forward.
Sir, how do we run that in the terminal?
So you type SWIPL, and then the prologue, this REPL will come. Once SWIPL comes, you type consult, and then in single quotes the file name. So intro.pl, PL is just the file extension, and then with a dot at the end. No, not PL, sorry. It was Pro. Hello.
Yes, sir.
Managed.
Yes, sir.
So you manage this example.
Sir, I'm trying to compile it.
Sir, while writing human H, can
Yeah.
we only like input capital letter?
No. Yeah. So you everything has to start with a small letter. Okay. For the moment, except variables. So yeah, that is one thing. So this is a practice followed by Haskell and Prolog and all these things. Haskell, Prolog is older than Haskell. Is that small letters are atoms or atoms, identifiers, constants, etc. etc. Those start with small letter are atoms or constants. Okay. Those that start with capital letter are variables. Okay. So we have two kinds of things already. For instance, you might have noticed it already that we have Socrates, which is a constant, and X, which is a variable. So everything which starts with a capital letter is a variable. Everything that starts a small letter is an atom. Okay. For instance, human is a relation, which is an atom. Hypatia is a atom. Okay. On the other hand, X is a variable. So we have two kinds of things in our language, and we have only two kinds of things. There are no types and other things. Okay.
Yes, sir.
All right.
So could you give examples where currently Prolog is used in systems?
Prolog is mainly used in query answering systems where you have large number of facts. For instance, natural language processing, where imagine you want to abstract out or planning systems. Okay, imagine you have some sort of a planning system. Planning systems are systems where you have rules and facts and all these things, and so it's a domain specific language. It is not used for general purpose computation, but it is used for autonomous systems, where it has to deduce what to be done next, and such kind of things. Prolog is used. So in the 80s, what happened was that the Japanese invested a lot of money into Prolog as the 5th generation programming language and so on. But it hasn't reached anywhere. But because Prolog, I don't think will ever be accepted as a general purpose language because of its nature. As you go along, you will see what is this language, because at the moment you don't have a flavor of how computation is done in this language. But as you go along, you will see that it is useful for presenting rule-based computation. If I want to abstract out rules, and if my computation is essentially finding out a solution which follows the rules, then Prolog is very useful. But if otherwise, Prolog is not. That's the only thing which Prolog is very good for. Okay, and yeah. Now, Prolog has had its influence, because you will see that Prolog has introduced many ideas into other languages. Like you will see that Prolog's influence in Haskell and Scala and all these things. Because, for instance, pattern matching. When you want to write a function, you write it as a bunch of patterns. That's something which was contributed by Prolog. Okay, so let's move ahead. Yeah.
Sure, sir.
All right. So now let's do another. Let me finish what I was saying. So rule based means that there are facts and rules, and computation is essentially query answering. Okay. By query answering, I mean I have an unknown, and then the system will suggest me what is that unknown value which I should take to be. What is the solution for that? Now, what is declarative programming? Declarative programming. Programming is program code is essential is describing what instead of how. Okay, so in essence, when you write code in Prolog, you are telling the system what is something instead of how is something done. Okay, that's also not very meaningful at the moment, because whenever we want to, if we code in C or even in functional paradigm, when we describe something, when we describe computation, we are actually saying, this is what you should do when I get this. Yeah, it is describing a how. But in Prolog, what you are actually describing is, you are actually saying what is something. You say something is mortal if it is human, and these are humans, and so on. Yeah, you are not describing how, you're just describing what, and the Prolog system manages to figure out what the how. Yeah, in a nice fashion. Now let's take another example. Okay, so here I have some facts and some rules. Okay, now what are the rules? It says that Edward is male, Albert is male, Victoria is female, Alice is female. Okay, and Albert is a parent of Edward, and Victoria is also a parent of Edward. Okay, these are facts. So already see that facts need not be just unary functions, it can be binary function also. Here the relation parent is between two atoms. These things, Edward, Albert, Victoria, Alice, these things are called atoms. Okay, and so relations need not be just unary predicate, it can be binary predicate also. So it says that Albert is a parent of Edward, and similarly Victoria is a parent of Edward. Now I'm describing a rule. What is the rule? Says that x father of xy. X is a father of y if x is a parent of y and x is a male. Okay, so comma is used for conjunction or Boolean AND. Okay, so if I say father of xy, then if father of x is a father of y if x is a parent of y and male of x. Okay, and x is the mother of y if x is a parent of y and x is a female. All right, so comma is and this is if. Clear? Clear?
Yes, sir.
Yes, sir.
Okay, so now let me introduce family.pro. Okay, if I consult this one and if I ask who is a parent of, I can, for instance, I can ask give me x and y such that x is a parent of y. Okay, that's one query I can ask, and in which case I'll get Albert and Edward. X is Albert and y is Edward, then father of xy is satisfied. And is there anything else? And there is nobody else. That's the only solution. Okay, that's why it says false, because that's the only solution. I can also ask is there an x such that x is the father of Albert? And that also says no, there is no solution. Okay, clear? So query answering need not always have only variables. It can also have atoms. All right. Okay. Now, I'm using this slides. This is from University of Toronto. I will post it in our this thing, in our Piazza. Okay. So let us. This is the example which we did. Okay. Yeah. So far we were using the C style comments. You can use that, or you can use percentage, the text style comments. Okay. And this we have already seen how to do this one. And okay. Now, what are the rules? So we have, I already told you that there are two kinds of things in Prolog: atoms and variables. Atoms are also called constants. Okay. So sequence of letters, digits, underscore that starts with lowercase letters. Anything which starts with a lowercase letter is a constant. So for instance, Mary, Anna, x25, x underscore 25, alpha, beta, etc. atoms. Numbers are also atoms. Numbers are also constants. 1.001, 2, 3.03, and so on. And everything which is enclosed in single quotes are also atoms. Okay. And variables must start with either uppercase letter or an underscore. And it can be a single underscore. Okay, single underscore has a special meaning. So what is a special meaning of single underscore? It can be taken to be a arbitrary value, like wildcard character. Okay, so for instance,
It's 11 o'clock.
for instance, if I say mortal of x, what should it mean? What is the meaning of this? If I say mortal of x dot, what could it mean?
Sir, maybe it means that model of x is always true.
Yes. And what is x? it could mean, it will mean that for any value of x, mortal of x is true. That means all are mortal. Yeah. So so this actually means that everybody is a mortal, or for any value of x, mortal of x will be true. But I think a more appropriate thing would be to use an underscore, because we don't care what is that particular value of x. So mortal of underscore, that means that for any underscore is again another variable. But the good thing is that underscore can be used in if I can use underscore, if I use underscore here and underscores here. So let's understand what is one special thing about these variables. So when I have father of xy, okay, and x is some particular value of x, that same value of x has to be used in this x and this x. Okay. So if I want to prove that father of, let's say, a comma b, a and b are some atoms, then in order to prove that, I should actually prove parent of ab and male of a. These are the two things I have to prove. If I want to show that father of a b, these are not variables, these are atoms. If I want to prove that the constant a is the father of constant b, then I have to prove that constant a is a parent of constant b and constant a is a male. Okay, so this rule actually summarizes that for any value of x, I have to use the same value of x here and here. But in the case of underscore, if I use here like this, then this has a different meaning. What does this mean? This means that these values can be different. Yeah. If I want to prove that somebody is a father of y, then all I have to prove is that somebody is a father of y and male of. If I use this, then these underscores need not be the same value. I hope it is clear. If it is not clear, don't worry. That will be clear. That will be clear as we move forward. Okay.
Sir, I had a question.
Yeah.
Sir, is the order, you are always writing it in the specific order that x is the father of y, so you are writing in that order. Can we reverse it? Can we say that y is the father of x?
Yeah, you can do that. It doesn't matter. So if I just consistently, if I do this and parent of y x.
No, sir, writing it in the same order but then function operating differently.
I didn't understand. What do you mean by that?
Sir, whenever you write any function, then you apply, like, there's a set order in which you are saying that father of xy, then x is the father of y.
Yeah, so you could mean differently. It's just that here when I do the parent, I am meaning that I mean that the order in which I have written this one is that I mean that Albert is the father of Edward. That's why I say that way. But you could also define it the other way. You could say that Edward is the father of parent of Albert, but you have to write your rules according to that. Clear?
Okay. Okay, sir. It's
Yeah,
dependent on the rules, right? Then.
yeah, it is dependent upon your choice. You choose it one way and you represent it consistently that way. That's all.
Okay, sir. Got
All
it.
right. Okay. Okay, so these are the constants and variables. So our language has only two kinds of things: constants and variables. Constants are anything which starts with lowercase letter. Variables are anything which starts with an uppercase letter. Okay. And then we have relations, or what they call structures. They're like functions. So what is their what do they look like? There is an identifier, and then there are some terms. Okay. For instance, date 1 May 1983. These are, one is a constant, May is a constant, 1983 is a constant. So it's an identifier followed by three constants. But you need not have always constants. You can also have variable. So I could say point xyz. Okay. All right. And this definition can be recursive also. Okay. The meaning is that you could write in first order logic. When you run first order logic, you have three kinds of things. You have relations, you have objects, you have relations, and you have functions. Okay. So here these +1 plus is a function. It's not a relation. So what that means is that if I sum 0 and 1 with plus, that is a value of this term. Okay. But yeah, more about this later. If I write, yeah, also write it as 0 plus 1. Prolog won't complain. Okay. More of it later. Structures can be represented as a tree. So if I have a term, I mean, if I have a relation or a structure like this, how would it look like? It will be a date at the root. Then it has three arguments: this term and this term and this term. So 0 plus 1, the May, and 1900 plus 0 1. Okay, these three terms. Yeah, let's skip this. Let's skip that list also. Okay, so we'll come to lists and this thing later, but let's look at how a Prolog program operates. Okay, so as I told you already, a Prolog program consists of a collection of facts and rules. A fact is a predicate terminated by period dot. So in our case, this is a fact. It's a relation which is followed by a dot. This is equivalent to mail Edward, then nothing. Okay, that means that if mail Edward, if nothing, that means from emptiness I can get mail Edward. That means in order to prove mail Edward, I don't need to prove anything. I can, if I have an empty premise, I can conclude from that mail Edward. So mail Edward dot is simply equivalent to mail Edward if dot. Okay. All right. Facts make assertions. So I could say elephant of Mary taller than John Fred, parent of X. So if I write parent of X, everyone is a parent. Not that X is a variable. X can take any term as its value. So this fact asserts that for every value of X, parent of X is true. And what are rules like? Rules are just a relation follow if some other relations, comma. Yeah. And what is so this has a particular form. What is this particular form? Okay, so let me take a detour. So if I write P implies Q, that is equivalent to what? Equivalent to P implies Q is equivalent to negation P or Q. Yeah, this everybody understands. Yeah, I think this is one of the.
Yes, sir.
Yeah, this is one
We
of the.
just saw that in that request.
Yeah. Now all Prolog rules are of this form. P implies all Prolog rules. All Prolog rules are of the form P implies Q1, Q2, Q3 implies P. Or I should say P1, P2, P3 implies Q. This is how all prologue rules are of the form. Okay. And so this is what we write it as Q if P1, P2, P3. Okay, we write it in the reverse fashion. So I should not use it. So P1, P2, P3 implies Q. That is what we will write it as Q if P1, P2, P3. All right. Now, what is this equivalent to? Equivalent to? It is actually equivalent to negation P1 or negation P2 or negation P3 or Q. Okay. Okay. And such clauses, a disjunction. What do you mean by disjunction?
Boolean or.
Boolean or, yeah. A disjunction of literals with at most one positive literal is called a horn clause. Okay. All prologue rules facts are horn clauses. Okay. What do I mean by that? What is a literal? A literal is if I have a relation, like if I have an atomic formula. All these things are called atomic formulas. Okay. You might have seen this term in your logic course, atomic formula. So either an atomic formula or the negation of an atomic formula is called a literal. All right. And so for instance, P1, P2, P3 are literals. Also negation P1, negation P2, negation P3, they are also literals because P1, P2, P3 are atomic formulas. And the definition of a literal is either an atomic formula or the negation of an atomic formula. So a disjunction of literals with at most one positive literal is called a horn clause. And so we have already seen that a prologue rule like Q1, Q if P1, P2, P3 is equivalent to negation P1 or negation P2 or negation P3 or Q. That there is exactly one a positive literal here. Positive means there is no negation in front. That's what we mean by positive. So Q is a positive literal. Similarly, if I have just a fact like Q, that's also a positive literal. Yeah, there are no negative literals in that. So all prologue rules are horn clauses. Did you understand what I just said? Should I explain it once more? Hello? Is that okay?
Sir, it was clear to me.
Yeah. So what I mean by that is that, yeah, the gist of what I was saying is that prologue rules are not arbitrary formulas. Prologue rules have very particular syntax, and that syntax is all formulas of this kind, P1, P2, P1 and P2 and P3 implies Q. All prologue rules are of this form. Okay. Now, why is it so important to have only a subset of formulas? The reason is because you might have seen this in your design and analysis of algorithms course that Boolean satisfiability is NP complete. Yeah. Boolean satisfiability or Boolean validity. Given a formula, checking if the formula is always true, or given a formula, checking if it is satisfiable is a very hard problem. Yeah. So
yes, sir.
But on the other hand, with horn clauses, everything is in polynomial time. Yeah. Polynomial time means that it is easy. That is the reason why we are restricting, prologue is restricting to horn clauses. Okay. All right. So things become easy with horn clauses. Anyway, so you can learn prologue without even knowing all these horn clauses and things like that. I was just telling you for the just to just to update you. Okay. All right. So all our prologue rules are of this form: a predicate head or a rule head. This is called the first element is called a rule head, followed by a conjunction of predicates or relations, followed by a period. Period means that it's a rule. Okay. First predicate is rule head, terminated by period. Rule encode ways of deriving or computing a new fact. So, for instance, animal of X if elephant of X. If we can show that X is an animal if we can show that it is an elephant. Taller than XY if height X H1, height Y H2, H1 greater than H2. Yeah, X is taller than Y if I can prove that height of X is H1, and if I can prove that height of Y is H2, and if I can prove that H1 is greater than H2. Okay, we can show that X is taller than Y if we can show that H1 is the height of X, H2 is the height of Y, and H1 is greater than H2. Taller than X, giant height X H1. Yeah. All right. Anyway, so when can I make so we missed a class on Monday. When can we do that class? Hello, Siddharth.
Yes, sir. Sir, tomorrow we have morning free.
What
And
about yeah? So shall we do it tomorrow?
yes, sir, that will be convenient to you.
Pardon?
So what will be convenient to you?
Yeah, any time is convenient for me. That's fine. Or let's discuss in the WhatsApp group. Okay.
Yes, sir, that will be good.
All right. Okay then. Let's meet later this week. And yeah, prologue is not very difficult. I mean, you will be able to do it in 2-3 classes. We will be able to finish off prologue, and then we'll move on to OOP. All right. Thanks, everybody. Hello.
Yes, sir.